welcome to screen working to Monday, May 18th. We are going to continue with our mixed review, chapters 1 through 12. We're going to do problems 29 through 40. We are going to skip number 39. So let's start it off. Number 1, so it has two equivalent fractions. The easiest way to complete this is through cross product. We know that any fraction that is equivalent, that the products across will always be equivalent. So we'll use that understanding, and we're going to use 4 times the quantity, 3x plus 5, must be equal to 8 times the quantity, x plus 6. We're going to distribute, which gives us 12x plus 20 equals 8x plus 48. Now we're going to isolate. We always move variables first, so I'm going to move my variables to the left. That gives me 4x plus 20 equals 48. And since I moved my variables to the left, let's move my constants to the right. We're given 4x equals 28 divided by 4. X equals 7. Now, we have to make sure that when we put 7 in the denominator that it doesn't make a 0. So if we plug 7 in, that's okay. And if we plug 7 in there, that's okay. That does not make it 0. So my only solution is 7. Number 30, we have a square root. What gets rid of a square root? A square. So we are going to square. The inverse of square root is squaring. So what we do to one side, we're going to do to the other. Now notice we are not squaring a variable that is, we're not taking the square root of a variable being squared. So we don't do plus or minus here. So we just are going to get rid of that square root by squaring. We're left with 3x minus 1 over 2 equals 16. And now we can solve for the variable. There's a number of things happening to the variable at the moment, this variable. 1 is being subtracted, 3 is being multiplied, and 2 is being divided. We can't get rid of this negative 1 because this 2 is under both of them. So we have to actually get rid of the 2 in the denominator first. So we're going to multiply both sides by 2. We're doing the inverse of dividing by 2, which is multiplying by 2. That gives me 3x minus 1 equals 32. And now this is a simple two-step. We're going to add 1. We get 3x equals 33 divided by 3. X equals 11. Again, we're going to go make sure that that doesn't make anything bad. And putting 11 in there works nicely. 3 times 33 minus 1 is 32. Divided by 2 is 16. Square root of 16 is 4. Now we'll do a quick check. Don't be afraid to check your answers and make sure that it makes the equation true. Again, we are going to square each side because that's what gets rid of a square root. That leaves me with y equals, that's 2 squared over 3 squared. We're going to distribute. We can distribute exponents through multiplication and division. We cannot distribute exponents through addition and subtraction. So y equals 4/9. Check it out. Square root of 4/9 equals 2/3. So that works. 4/9 is my solution. This is not a compound inequality. This is a single inequality. It's a two-step inequality. Two-step because 2 things are happening to it. Negative 3/4 is multiplying it, and 2 is being added to it. How do I know it's being added? Because that's a positive 2. So what are we going to get rid of first? We're going to get rid of the things being added and subtracted to it. So we're going to subtract 2 from both sides. And then we have negative 2 and positive 1/3. Negative 2 plus 1/3 Well, we have to convert this into thirds, so that makes -6/3. And +1/3 gives me -5/3. So we're going to have -5/3 is less than -3/4 y. We're going to multiply by the reciprocal. We wouldn't want to divide by -3/4. That's crazy because who wants to have that crazy superfraction? So whenever we have fractions multiplying and we're trying to isolate, we don't do the inverse of division or multiplication by doing division. We do the inverse of multiplication, which is also multiplying by the reciprocal. So we're going to multiply both sides by -4/3. Remember, whenever we multiply or divide both sides by a negative, we have to flip the inequality sign. So that now becomes greater than. That is y. Negative times a negative is positive. Nothing cancels. That's going to be 20/9. So I can have that as my solution, or I always like having the variable first. So we're going to have y as less than 20/9 is my solution. I think that's the best one. Since it's eating the 20/9, when we rewrite it with the variable, it's still eating 20/9. Number 33, we have a variable being squared, so we're going to isolate it. I'm going to isolate it since there's only one variable. Remember, we have 4 different ways of isolating variables being squared. We can factor and use the 0 property. We can solve for the variable by taking the square root. And we use that when there's only one variable in the problem, meaning you have a t squared only, not t squared and then t to the first. Then we can complete the square, and we can use the quadratic formula. So we could use a quadratic formula in this case. We can't complete the square. We can solve but for the variable, which is what we're going to use. And could we factor? 5 divided by 80. I should know what 5 divided by 80 is. It's 18. Yeah, 18. 18 is not a perfect square, so I would probably not factor that. Definitely wouldn't factor it. So I would either use quadratic formula or solve for the variable. We're going to solve for the variable here. And we get 5t squared equals 80 divided by 5. We get t squared equals, I think I said 18. Oh, it's not 18. Mr. Mac, it's 16. So I could have factored in the 0 property. But we're going to do this much easier. We're going to take the square root of t squared equals plus or minus square root of 16. We introduce plus or minus because we're taking the square root of a variable being squared. We get t equals plus or minus 4. And that would be my answer. And we can have the negative because when we plug in -4 and square it, it gives me the same value as positive 4 squared. Here we just have variables on 2 different sides. Let's move the variables to one side. I'm going to move the t's, the variables, to the left. That gives me t plus 2 equals -1. I'm going to subtract 2. I'm going to move my constants to the right. And my solution is -3. It's nice and easy now looking back at this. Same thing, we have an inequality. We're going to move the variables first. We get 2 is less than 2t minus 3. We're going to add 3. We get 5 is less than 2t. Divided by 2. We get 5 halves is less than t. I always like to put my variable first in my solutions. So I'm going to get t is greater than 5 halves. Don't think that it says to graph these. We have a variable being squared, so we're going to take the square root of it. Whenever we take the square root of a variable being squared, we're going to introduce plus or minus. We get x plus 3 ooh, this worked out. I probably actually should have set it equal to 0. But this is okay. This worked out in this case. I'll repeat this problem and do it the other way. Minus 3, we get x equals negative 3 plus or minus 4. So remember, this is what we did just in the last couple of weeks. We're going to separate it into negative 3 plus 4 and negative 3 minus 4. We get 1 and negative 7. So my solutions are negative 7 and 1. Negative 7 is fine, and positive 1 is fine, because we're going to square that negative value. If we plug in negative 7, we get negative 4 squared is positive 16. Let's take this problem, copy, and let's show how we can do it a little bit more time consuming. So we would set this equal to 0. Well, we have to simplify that binomial square. So we get x squared plus 3x plus 3x plus 9 equals 16. X squared plus 6x plus 9 equals 16. Set it equal to 0. And that is minus 7 equals 0. So here we go again. We have 4 choices. We can factor and 0 property. We can solve for the variable. We can complete the square. And we can use the quadratic formula. So let's talk about this. We can factor by 0, and that's what we're going to do here. We cannot solve for the variable because there are 2 variables, x squared and x. We can't isolate the variable. We can complete the square, and they've already completed the square. They created it, so completing the square would take you down this, right? We take the square root. That's when we complete the square, we end up getting this equation. So we wouldn't complete the square in this instance because it's already completed. And then we could use the quadratic formula, but remember, we have to make sure that it's set equal to 0. We can't use the quadratic formula in this format. It's only until here can we do factor 0 and quadratic formula. So let's continue to factor. Factors of this factor meaning a times c. 1 times negative 7 is negative 7. Factors of 7 are 1 and 7. Signs are different. Bigger is positive. And you get 6. That is my middle. You get x squared minus x plus 7x minus 7 equals 0. Factor by grouping. We're going to factor out an x. Factor out a positive 7. You get x minus 1, x plus 7 equals 0. We're going to set each one equal to 0. Remember, that's what the 0 property allows us to do. We're going to add 1. We're going to subtract 7. And my solutions are still negative 7 and 1. We would get those same values if we use the quadratic formula. Solve each system. So there's a number of ways we can do this. We could graph it. Let's see what happens when we graph it. I don't know, I haven't done this yet. But we're going to plot each one. So remember, this may not work because our system, our solution to the system of equation is always an intersecting point. It's a point of intersection. And when we graph, it doesn't necessarily have to land on one of these grid marks. So it may end up being in this space here, and we won't be able to tell you what that point of intersection is. So graphing is not the most efficient way, but we'll try it in this one just to see how that goes. So we have it in standard form, so let's use the intercepts. The first equation, our x-intercept is going to be 7. Our y-intercept is also going to be 7. Remember, we cover the x up. We cover it up. Let's do this so you understand what I mean. So what I mean is if we cover this left side up, it says y equals 7. If we cover up the right side, meaning plugging 0 in there, because our intercepts always have x of 0 or y of 0, depending on which intercept, you see x equals 7. So in this case, in the green problem, if we solve for x now, our x-intercept is 2. So for my green one, well, let's draw my line for my blue one. Sorry about that. So this is my blue one. Yeah, that's not bad. That was really good. My blue one. Come here, blue. Let's draw some arrows on there. And now let's do our green. Our green, my x-intercept is 2. And if I go over here, my y-intercept is going to be 4/3. 4/3. Oops, sorry, my x is 2, and my y-intercept is 4/3. So 1 1/3. All right, that kind of looks like it's a parallel line. It's going to be very interesting to see. So, but I'm not able to determine that. I don't know, but it looks like it definitely, it doesn't look parallel. And it also doesn't, it doesn't intersect on our graph. So that method's not going to work. So we have to use a different method. And so with systems, we can use two different methods. We can use a substitution, or we can use addition and subtraction. So we have this equation, x plus y equals 7, and 2x plus 3y equals 4. So my variables, if I use the addition, my variables don't cancel out. But if I multiply this top by -2, that would produce -2x minus 2y equals -14. You see that I multiplied each one. And then you keep that bottom equation, because as you see now, my x's will cancel out. If I wanted my y's to cancel out, what would I multiply the numerator, or the top equation by? Yeah, -3. And that would cancel out the y's, and then we would isolate the x's. So in this case, the x's cancel out, and we're still adding, so we're left with y equals -10. So that's my y value. Now I take one of these original equations, and I'm going to plug it back into the equation. I'm going to use x plus y equals 7, and I'm going to plug the y into that and solve for it. Add 10, add 10, and I get x equals 17. So the point of intersection has an x value of 17 and a y value of -10. Now, we can use that graph. Does that make sense? Right? Where did we think that our intersecting point was going to be? Right? If you extend these lines out, where do you think they cross? Yeah, somewhere around there. Is that point 17, -10, somewhere around there? Yeah. 17 on x, 10 on y. Yeah, it's somewhere around in there. So that's a reasonable solution. I like it. You could also check by plugging your x and y and making sure that it makes both of those equations true. So the solution is 17, -10. Love those. Here we go again. I'm not even going to graph. I'm going to do the addition and multiplication. So we look, can my x's, are they relatively close? No, not really. How about my y's? Yeah, my y's are kind of close. If I can multiply that bottom equation by a value, I can cancel out my y's. So what do I want to multiply the bottom equation to cancel with my y in the numerator? Yeah, +2. So I'm going to distribute a 2 into each of those, which gives me 6x plus 4y equals 2. You always got to do everything on the left side and the right side. Students commonly make a mistake because they don't distribute it to everything. My y's cancel. I'm left with 11x equals 11. Divide by 11. I get x equals 1. That's my x coordinate for my solution to it. and I pick one of these two equations. I'm going to pick the bottom equation this time. And I'm going to plug in a 1 for x. 3 equals 2y equals 1. I'm going to subtract 3. I get rid of things being added and subtracted. And then I divide. And I'm left with y equals -1. So my solution is 1, -1. I have to use the coordinate sign because it's a point of intersection. And the last one, my favorite. I love these word problems where we talk about consecutive even integers. So when we talk about consecutive integers, let's talk about consecutive integers. So consecutive integers are x, x plus 1, x plus 2, x plus 3, ... So if x was 5, if I did 5 plus 1, I'd get 6, 5 plus 2 is 7, 5 plus 3 is 8, blah, blah, blah. So that will give me consecutive integers. How about consecutive even integers? How do we represent the first number? Well, it's x. What's the next number in that sequence? If it's even numbers would be x plus 2. What would the third number in that sequence be? X plus 4, good. X plus 6, ... What if I ask for consecutive odd integers? This is tricky. People make a lot of mistakes here. What's the first one? Well, it's going to be x. What's my next consecutive odd integer? What's it going to be? Is it going to be x plus, not 1, plus 2? Wait a second, Mr. Mack, you told me it has to be odd. Well, let's look at odd integers, consecutive odd integers. What do they have? 5 plus 2. 7 to 9 is plus 2. 9 to 11 is plus 2. Well, Mr. Mack, what makes it odd? Well, whatever your starting number will determine whether you start with odd or even. If you start with 8 and do plus 2, that's 10 plus 2 plus 2. So it only matters what you start with. Odd and even integers are always going to be 2 apart. So when we talk about consecutive numbers, it says the sum of 2 consecutive even integers is less than 84. So what's the first even integer? Well, I don't know what it is, so I'll call it x. What's the next even integer, consecutive integer? Well, that's going to be x plus 2. So when we say the sum of 2 consecutive integers, we're going to add the first even integer to the second even integer. So that's going to be x plus 2. This represents the first. This represents the second consecutive even integer. Is less than 84. So there's my starting equation. So let's simplify. We always want to simplify the equation or inequality first. We're going to combine like terms. And now this is a two-step equation. Get rid of things being added and subtracted first. 2x is less than 82. Divide by 2, and we get x is less than 41. So, Mr. Mack, what does that mean? X is less than 41. It says find the pair with the greatest sum. So, if I have to find an even integer, my first even integer is going to be less than 41. What's the next even integer less than 41? 40. Okay. And now, if x is 40, what's my second even integer? Well, it's going to be 40 plus 2, or 42. So my 2 consecutive even integers are going to be 40 and 42. And the sum of them gives me 82. Is 82 less than 84? Yep. What if my first even integer was 42? What would my second would be 44? 42 and 44 gives me 86. So that would not satisfy it. Remember, it says it has to have the greatest sum. So the pair with the greatest sum. If we use 38 and 40, well, that doesn't have a sum that is greater than 40 and 42. That's a great problem. Some good stuff. Hopefully you'll learn something here today. Come and see me if you have any questions with this.